Hello again. This lesson is called the Alkaseltzer investigation. In this investigation, students are going to observe and then create a model to explain the changes that they see when two Alkaseltzer tablets interact with the water that will be in this sealed plastic baggie container. Now, because this is an investigation later on in our unit, there's a lot going on that students can start synthesizing. By now, they should be using particles in all of their matter models for before and after explanations. Students have also been introduced to the idea of conservation of mass, and so this will be an opportunity once again to investigate that idea and to see if it is something that they can replicate or explain and understand in their data and in their model. Also in this lesson, we're going to see an interaction where the combination of two kinds of matter are going to create a new type of matter. And that matter in turn cannot be reversed back to the original matters. Right? This is the idea that when combining matter, some changes can be reversed and others cannot. So, in this investigation, you will need, along with 2 tablets of Alkaseltzer per pair, a graduated cylinder of water, plastic baggie, and some sort of weight measurement, in this case a digital scale. You're also probably going to want to use the tray from the ice cube melting investigation, and this will just help to keep all of your materials on the scale so that it can be weighed. You're also going to want to use your safety goggles during this investigation, as we are combining 2 different types of matter that create a chemical reaction. And as you will see, that reaction has the potential to possibly overflow. So, we are going to start, of course, by asking students to once again weigh the matters that they see. So in this case, we have some water. That water is going to be recorded at 76.1 grams. Then we're also going to weigh everything else in the system. The baggie, the tray, the Alkaseltzer, including the wrapper, which is going to be 27.8 grams. Right. Now, when this combination occurs in pairs, it tends to be a lot easier to manage. One student is going to hold the bag open. The water will be poured in, while the other student opens the Alkaseltzer container and very carefully drops both of those tablets into the baggie. It's important here to stress to students that as soon as those tablets enter the baggie, that baggie should be sealed and secured so that we create a closed system or closed container, right, to in an effort to test to see whether or not the mass is in fact conserved. So we're going to put those 2 tablets in, we're going to seal it up tight, and now we're going to spend a few minutes observing the changes to this system, right, of some matter. Now students will immediately observe that effervescence, if you will, that bubbling in the water. That bubbling in the water is, of course, evidence that new matter is being generated, created, along with the fact that the plastic baggie is now inflating. That is another sign that something is in there that wasn't previously there. And now this baggie is getting really full. And students are, of course, going to notice that the tablets seem to have mysteriously disappeared. Right? And where has that matter gone? So that's something else that they will have to explain through their models. Now we have completed the reaction, and we're weighing out everything together as one whole system now, a total, and we're getting that is going to make 103.9. So there does seem to be, again, a small amount of matter that's being lost. Now that's 0.8 grams. Is that enough to explain the complete disappearance of the 27.8 grams worth of our Alkaseltzer? Probably not. Right? Students are going to have to think a little bit about where that remaining mass might have gone. They might notice that the bag starts to deflate at some point, suggesting that maybe some matter could be escaping. Or maybe they had some other errors, like they dropped the tablet on the table, or it started to crumble before they added it, or they simply didn't zip it quickly enough and some of the gas began to escape the system. Whatever that may be, you'll want to have a conversation around that to help them reconcile their data with what we know to be true, that matter can't just magically be created or destroyed. It exists and it's recombining in different ways to create new matter, but it doesn't just disappear and it doesn't just come out of nowhere. Before combining the matter together, you'll want to make sure that students first complete the diagram section of their student notebook of matter before the mixture and the table to insert the weight of the two types of matter systems, all right, the watering container and the pan, baggie, and tablets into the appropriate column. Right? Again, once we put it all together and we measure later on, we'll want to determine the weight of everything after combining and insert that here. During the investigation and while our tablets are dissolving and creating all of that effervescence, students will want to be jotting down some observations they're seeing either visually or by touch, what is happening to the baggie, where the tablet's gone, etc. here to help them support their model on the next page. The Alkaseltzer particle model presents one of the trickier models your students are going to have to create. Because here in this model, we're asking them to share not only the stages of matter that they observed, specifically the liquid at the bottom of the container and the gas here, but also what is happening that would cause the bag to inflate, and also whether or not they think new matter has been made. Now you'll see here in my model, I've said water, liquid, that's pretty self-explanatory at this point. But my tablet I put I'm not sure, because the truth is that some kids are going to say that it's the tablet that's turned into a gas, right? While others are going to say that this is a new kind of matter. And really what ultimately you need to do as a teacher is to allow a conversation to be had between these two camps as to why they think one or the other. And ultimately allow them to perform a test, much like they might have done to allow the water to evaporate to see the sugar crystals return during the dissolving activity. If we do the same thing, will all of the matter from the tablet return? If it does, then it's safe to assume that it was there all along, much like the sugar. But if it doesn't, and it doesn't, it makes us think that this tablet has actually turned into something else. So some students are going to label this as tablet, some students are going to label this as new gas, some students are going to label this as, I don't know. Some students might demonstrate that it's a new type of matter or particle by maybe even changing the shape of the particle. Whatever they choose to do, make sure that it is conveyed here in the section below. How does your model explain what you observed and really what they're thinking moving forward about this system
of two different kinds of matter interacting. Okay? One thing that they should sort of demonstrate is that this matter, the amount of matter should have stayed the same. The mass should have remained constant, unless of course it was squeaking out the side of the bag.
In conclusion, use the Alkaseltzer investigation to support students building towards the standards of being able to measure and graph weights of substances before and after to provide evidence that the total weight of matter has been conserved, and to conduct an experiment to determine whether the mixing of two or more substances results in new substances with new properties. In this lesson, students support an argument with evidence that has been observed and their model to argue that the amount of matter has been conserved and that chemical reactions occur when substances are mixed and that those substances have different properties. Once again, students are using the cross-cutting concept that when matter flows in a system, the total weight of substances does not change. This video and associated lesson has been produced by the Burlington, Massachusetts Science Center.